Okay, we are asked to begin by sketching a graph of the y equals x cubed function. Now we should be able to sketch that graph very, very quickly, and really we just want to sketch the shape of the graph, but we want to get it reasonably good. So I would recommend starting with the x equals 0, 1/2, 1, and 2 points, and just locating them approximately, and then using symmetry to construct the rest to get a reasonably good facsimile of that graph. But it doesn't have to be hugely accurate. It just has to have the right basic characteristics. Now you should have done that on your own before you see the one that we have here, but right here it is. We understand the graph looks like this, and we understand that it levels off at x equals 0. Now we're asked to sketch a series of tangent lines so that we can look at the trend of the tangent lines. Now some people maybe sketch 2 tangent lines. Okay, well I wouldn't call 2 tangent lines a series. Okay, when we say a series of tangent lines, and I'm not being critical or anything, just trying to explain the intent here, that means probably at least, it would mean at least 3, but it would probably mean several. Okay, so what I've done is I've sketched 1, 2, 3 on this side of the y-axis, 1, 2, 3 on this side, tangent lines, and then a tangent line at the origin. That gives me 7 tangent lines. And then we look at the trend of these tangent lines. So what is the trend of the tangent lines? Well, you should think about how you would answer that question before you listen to my answer. Okay, well, now my answer, so I hope you've paused and thought about it if you haven't previously. My answer is that the tangent lines, as we start over here, as x goes from negative to positive, as the x value increases, we've got a tangent line that's pretty steep here. That's a pretty high positive slope. Okay, it looks like it has a slope of 5 or 6. And then here we have a lesser slope, maybe about 3. And then a lesser slope here, maybe less than 1, then a slope 0, and then a greater slope again, positive slope, maybe a slope of 1 or so, maybe a slope of 2 or 3, maybe a slope of 5 or 6. Okay, well, the point is the slope is decreasing as we move from here to here, and that is a trend that we need to observe, and that we would hopefully observe. So we have a decreasing slope that decreases to 0, if you're aware that the graph really does level off at 0. Okay, then and of course if you draw the graph, most people when they draw the graph don't really get it level there, so you might not realize that that slope is 0, but take my word for it, as you'll see very soon, it is. Then the slope starts increasing. So we've got a slope that decreases up to here, and then it starts increasing again, and that's the trend of the slope. Now you were asked then to sketch a graph that would represent slope versus x. Okay, how would you do that? Well, you would have numbers decreasing towards 0, and they would actually hit 0, and then they would be increasing again. So you have slopes that are positive but approaching 0. And if you don't have this being level here, maybe it's approaching some small number, okay? But it's approaching, it's in fact positive but approaching 0. So you have decreasing slopes. And then you have increasing slopes, increasing away from 0. Now, what's a graph where the slope is on the, slope is represented on this axis, and the x is represented on this axis. You're going to want, for negative values of x, you're going to want decreasing slopes that decrease, decreasing values that decrease towards 0. And then you're going to have increasing values that increase from 0. So if your slope is here and your x is here, you could have any of these graphs. I've got 4 different graphs in 4 different colors. Okay, maybe you have this purple graph that comes down to the origin, then just turns around and comes up this way. It looks kind of like a V. That would be perfectly consistent with the trend that we've observed here. Maybe it comes in like this blue graph, okay? Concave down here and then concave up here. That's also decreasing towards 0 and then increasing as you go away from 0. Some people drew graphs like the purple one. Some people drew graphs like the blue one. And then some people drew graphs, kind of a U-shaped graph, maybe a parabola perhaps. That would be the yellow graph. Now, the one graph that I've drawn up here, kind of facetiously, but this graph here, the green graph that comes down here and then goes all wavy. Well, it still has the characteristics. It's decreasing as we approach x equals 0, and then it's increasing after x equals 0. Now, it's decreasing at a steady rate and increasing at a less steady rate, not very steady at all, but it's still decreasing to the left of the y-axis and increasing to the right of the y-axis. And that's exactly what the slopes do. They decrease and then they increase. Now, we're going to reject this green graph. It's just too weird, but that's not why we're going to reject it. We're going to reject it because the x cubed graph has some symmetry. Now, it's a symmetry with respect to the origin, but we can see that these slopes are going to have a symmetry also. And just what the nature of that symmetry is, we don't have to analyze right now, but we know there's going to be symmetry of some kind on both sides, from one side of the y-axis to the other. And this graph is not at all symmetric in any way. So we can reject that because x cubed has symmetry. Its slopes will turn out to have some symmetry, and this graph doesn't. So it just has to be rejected. It just doesn't have a symmetry that has any relationship at all with the x cubed symmetry. Okay? Now, let's be sure we understand how we arrive at this graph. On this graph, the slopes are positive up to x equals 0 and decreasing. Okay, positive slopes decreasing as x increases. So as x increases, slopes decrease but remain positive. Okay? Then on the other side of 0, past x equals 0, the slopes are positive and increasing. Well then, if we're going to graph the slope versus x, then the y values are going to be positive and decreasing here, just as the slopes are positive and decreasing here, because the y values are now the slopes. And since the slopes here are positive and increasing, the values of the graph will be positive and increasing. So, we need to understand those relationships. Now we're going to proceed with some analysis that will tell us which of these shapes, if any, is the appropriate shape for the graph of slope of the x cubed graph versus x.